Okay, we are looking at this rectangular tank here, shown with its top at ground level, is used to catch runoff water. And we're told in this example that water weighs 62.4 pounds per cubic foot. How much work does it take to empty the tank by pumping the water back to ground level once the tank is full? Okay, so our tank here you can see is 30 feet deep, and it's 9 feet by 10 feet. So obviously it's pretty easy to figure out the volume, but we need to figure out how much work it's going to take. And so what I'm going to do here is I need to write my integral here. And so I need to go from 0 to 30, okay? And then what I need here is I need my weight of my water, 62.4 in this example. And then I need my cross section. So my width here is going to be y. And then I need my the volume of a slab, right? My depth, I don't know what is. That's what's changing here. But my volume, that's always 9 times 10, right? That's just 90 dy. And so this is what I'm going to evaluate. So I'm going to switch colors here. And so the first thing I want to do is I want to kind of do a little cleanup here. I want to do whatever 90 times 62.4 is. So I have 5616. And let's see here, my integral is going to be 1/2 y squared between 30 and 0. Okay, so I'm going to divide that by 2. And I've got 2808. And then I've got 30 squared minus 0 squared, which that isn't that exciting. So I'm going to do this 2830 times 30 squared, and I get this big number, 2527,200. And so now I'm going to go back. I'm going to put that in here. Let's see here. 2527. I left up my calculator. 200. Check answer. That makes me feel just as good as it does you, so don't feel like you're not the only one. Okay, so that's how much work it takes foot per pound. Now, if the water is pumped to the ground level with this horsepower motor, which has an output of 200 feet per pound, how long will it take to empty the tank? Okay, well, we want the nearest minute, so the first thing I'm going to do, come back over here, is so then I need to divide this. I mean, it's going to take 200, right? But then I'm going to also need to divide it by 60 to get from seconds, because you notice this gave us this in seconds, and then get to minutes. So I'm going to take that 2527,200, divide it by 200, that's my rate, and I'm going to divide it by another 60, get it to minutes, and then I'm going to round, and I have 211 minutes. And we got it right. So you can see a lot of this is looking at the picture and figuring out the pieces you need. The formula you need is on page 342. That's going to be, the weight. That's going to be whatever the weight of your object is, whether it's milk or whether it's, in this case, water, usually water. And then strip depth, that's going to be your changing. Sometimes it'll be, but in a lot of cases, that's going to be your dy. One of these is usually going to be your variable. And then you want your function here. And in this case, this is a constant here. It's not changing. It's always the same little rectangular area here. We know how to find the area of a rectangle, and that's really what we're doing. Some of the examples, we see like a cone where the area is going down. You have to work a little bit harder. But something like this, the area of the slab is constant from top to bottom. The only thing that changes is how much of that slab we're getting, and we're obviously trying to figure out the whole process. But we're at a constant rate really because the volume isn't changing. So you need to pay attention to whether the volume will change as you go down. So like a cone, As you go down, it gets narrower, and so there's less in the bottom than there is, say, in the top 2 inches, the bottom 2 inches. There's more liquid in the top 2 inches than there is in the bottom 2 inches. In this, the amount in the bottom 2 inches and the top 2 inches are the same. So that is something in these problems you need to watch for.